This is Chapter 1, Lesson 6. Lesson 6 is all about solving proportional relationships. So this is a big one for us, a lot of problem solving in this lesson. We will start off with some vocab words. Our first word is proportion. A proportion is a relationship in which two or more ratios are equivalent. So the idea here is that we've got these equivalent ratios going on. And that might mean that we have to do a little simplifying, do a little bit of finding unit rates, or we can use what we call cross products, which is our other vocab word for this lesson. Cross products, this is a method used to solve for a missing element in a proportional relationship. Okay, so make sure that definition gets copied down. Also, you have some space underneath that. You should write this example. If we have a ratio A over B, and we know that that's equal to the ratio C over D, then this is what's called a proportion. So if we're given a proportion, then we can use cross products to solve it or to prove that it is proportional. And that's when we multiply diagonally, A times D, we get the product AD. Here we multiply in the other direction, B times C, and we get the product BC. And we know that if this is a proportion, then our two products will be equal. So we will see this happening today in a couple practice problems. One fast note for 1.6, if two ratios form a proportion, then their cross products will always be equal. So we will see how that helps us to solve some practice problems. In fact, it helps us solve a lot of real-life problems that deal with proportional relationships. So this is our first practice problem. This is just a basic problem, no word problems. This is just telling us that we have a ratio here and another ratio, and they are equivalent, so that means that this is a proportion. And if we know they're equivalent, then we can use cross products to solve for our missing number x. This is on page 8 of your notes. This is number 1, so you should be following along in your note packet right now. So when we do cross products, I always like to begin with the problem that is going to contain the variable. So 10 times x, we write that as 10x. And we know that we are going to be setting up an equation here, so you must remember to bring your equal sign down. Then we can do our other multiplication, 4 times 9, and that is 36. So we got a really nice equation here, 10x equals 36. If you remember from 6th grade, in order to solve an equation, we have to undo the operation that's happening on the variable side. So this says 10 times x. In order to get rid of that 10, we have to use the inverse of multiplication, which is division, and we will divide it by the 10 to kind of cancel that guy out. But we have to keep equations balanced, so if I divide the left side by 10, I have to divide the right side by 10 as well. So 10x divided by 10 leaves me with a lonely x. That's what we want, our x all by itself. 36 divided by 10, I could set up a house and do this as a long division problem, but I know a cheat for dividing by 10. Dividing by 10 takes my decimal and moves it one place to the left. So my final answer of 36 divided by 10 is 3 6/10. So the missing number here for x would be 3 6/10, and that makes my two ratios equivalent. Let's see an actual word problem here. This one's about cookies. This is also from your note packet. It is number 5, so you should be following along in your notes as well. We've got a girl named Andrea, and she's baking chocolate chip cookies. She wants to bake 8 cookies for every 6 people attending a party. So that's that important ratio that's sticking out to us. 8 cookies for every 6 people. I'm going to underline that. 8 cookies for every 6 people. This set of words here, for every, that is a big ratio word for us. That's a word that tells us that we're linking two quantities together. So pay attention when you see the words for every or for each. Oftentimes that's going to be setting up a ratio. The rest of the problem says if 27 people are attending the party, then how many cookies should Andrea bake? Well, let's start with our ratio. Our ratio says she wants to bake 8 cookies. I'm just going to use C to show that I'm talking about cookies here. She wants to bake 8 cookies for every 6 people. I'll use P to represent people. So these are units. Remember, we're setting up ratios. Actually, this would be a rate because we have units in our problem. So since we're setting up that rate, we're showing that our units go along with our numbers. This is a proportional problem because she wants to make sure that ratio gets repeated and that applies when there are 27 people there. So what we have to do is set up the rest of our ratio, and we have to decide where to put the 27. Well, 27 represents the number of people, so that will come down here and line up with our 6 people from our original rate. And that leaves us with a missing piece here in our proportion, so I'm going to use the variable x to fill that spot. So now that I've got my proportion ready to go, I can use cross products to solve it. I always start with the multiplication problem that's going to contain the variable. Remember, x is the variable here. The C just represents the units of cookies, and the P just represents the units of people. So we don't have to use these guys in our math problem, but we do have to use the x. So we get 6 times x, which is 6x. Don't forget we're writing an equation, so put your equal sign there. And now we're going to multiply 8 times 27. 8 times 27 I'll show real fast over here in the margin. 8 times 7 is 56. 8 times 2 is 16 plus 5 is 21. So we get 216. So our equation is 6x equals 216. I want to get my x all by itself, so I have to divide both sides by 6. That leaves me with an x all alone. That's what I want. Don't forget to bring down your equal sign. And 216 divided by 6, we can show really fast right here. 6 goes into 21 3 times. 6 times 3 is 18. Running out of room here. When I bring down my 6, I get 36, and 6 goes into 36 6 times. So that tells me that if Andrea knows there are 27 people coming to the party and she wants to bake her cookies in that specific ratio at the top, then she needs to bake 36 cookies to make sure that she has enough cookies for every person at the party. Okay, so this is how we use proportions to solve word problems. We write our proportion, we line up our like units, people and people, cookies and cookies, and then we can cross multiply. There's another word problem in your packet that I want to draw your attention to. There's actually 2 other word problems, but number 6 is the one that I want you to think about for a second. Number 6 talks about Matt. He's planting fruit trees in his orchard, and he has a specific ratio that he wants to adhere to when planting those trees. So he wants to plant, for every 3 apple trees, he wants to plant 2 peach trees. So that is a ratio that's very important to this problem. But when we go on reading the rest of the problem, it says that Matt wants to plant 15 trees in all. So this is going to look a little bit different than number 5, but I don't really want to give it away just yet. I want to see if you can try this problem, try a couple different ways to set it up. I will give you a hint. You may need to use a little bit of addition in this problem. Okay, and then we're answering 2 different questions. First, we want to know how many apple trees he's planting. Second, we want to know how many peach trees he'll be planting. So, muddle through this, give it a go. It's not too bad, but I wanted to prepare you that it does look different than the other one, so save this for last. Your to-do list for today, finish up all your practice problems for 1.6. I think there are about 5 of them. I would like you to update your flashcards with your new vocab words, proportion, and cross products. After this, you are ready to take the Chapter 1 Quiz 2. So if you're ready, you can start taking that quiz. There's also a 1.6 enrichment video that you can watch. It shows us a different way to solve these types of problems without cross products. And then when you're ready, move on to lesson 1.7.